Hi, seventh grade. I hope you had a good weekend. Um, well, for this week and the coming weeks for distance learning, what we're going to try to do is upload some video lessons in addition to the PowerPoints. This way, we hope to feel more connected with one another and um, maybe it'll help you more. I don't know. Let's just give it a shot. And if you have any tips, to improve these video lessons, let me know during our next GoToMeeting session, okay? All right, so here we go. I'm going to enlarge the PowerPoint. Oh, shoot. Did I? Let me see. Did I make sure that floated on top? Okay, cool. Let's see, how do I make this slideshow play from start? Okay. Oh man, I hope that recording leaves the little red recording. Is it not? Oh, there we go. Okay. Well, first off, so good to see you again. This Pikachu made me really happy. How I feel about you guys and hopefully seeing you guys in person soon. Anyways, these little gifts will have to do for now. Well, today we're going to learn about the surface area of a sphere. I apologize that my face is covering the title. Now, do you recall a cylinder, right? So a cylinder, I have to point this way, not this way, this way. Okay. A cylinder has two circles at the top and bottom, and then it has a curved surface, right? Okay. And the circles have a radius. And if we kind of pull apart just the covering of a cylinder, you'll see that it looks like that, right? There's the two bases, right? And then we have the curved surface. And if we lay it out flat, it's actually what shape is that? Yeah, it's a rectangle, isn't it? And if we just talk about the surface area of a cylinder, we can see that it is just the area of the two bases, right? The area of a circle is pi r squared, but two of those circles are 2 times pi r squared. Okay, so that's the area of the bases plus the area of the curved surface. Now look at the curved surface on the screen, right? We have a length times width, don't we? With the rectangle that represents the curved surface of a cylinder, right? The length, we can call it 2 pi r, and then the width, we can call it h. And the area of a rectangle is length times width. In this case, it is length is 2 pi r and width is h. So the area of the curved surface is 2 pi r times h. Do you see that? Okay. And I just wanted to highlight that part for you. I just wanted to highlight the area of a curved surface for you, not with the bases, okay? But you know that the length is 2 pi r because that represents the circumference of a circle, right? Because the cylinder curved surface, it actually measures the circumference of a circle, the length, okay? All right. We'll talk about it more if you have questions. Now, I really want to upload this video for you because it's awesome. It actually correlates with the hands-on activity in your book in, are we doing 8.4? I think it's in 8.4. And it was really great, but I couldn't upload it for some reason, but you could look for it. So I want you to look for this video on YouTube right now, okay? You go to youtube.com and look for Finding the Surface Area of a Sphere. And then it's uploaded by Technical Dips. And the video is only 3 minutes and 33 seconds long. So we're going to figure out, I know how to find the surface area of a cylinder, and I know how to find the area of the curved surface of a cylinder. With that information, can I find the surface area of a sphere? And the answer is yes. And so please watch this video, okay? Pause this video now and look it up on YouTube and watch it for 3.5 minutes, okay? I promise you it's really cool and worth it, okay? I'll be right back and get the book, to get the book. All right, I really hope you watched the video and you enjoyed it, and ideas were clicking to see, wait a minute, how is this equation gotten from what we know about the surface area of a cylinder? And so, therefore, the surface area of a sphere is 4 times pi r squared. Okay. All right, so let's do this example. Find the surface area of a sphere. Remember the formula was 4 times pi r squared, right? For the surface area of a sphere, okay? And so let's do example 14 on your own. Let me read the question and then you can pause the video so you can figure it out. A sphere has a radius of 3 centimeters. What is the surface area of the sphere? Use 3.14 as an approximation for pi. All right, so pause the video, work it out on your own, and when you're ready and you solved it on your own, play the video again, and I'm gonna do it with you to see, if we were on the right track, or if we, had some questions, or, you needed clarification. I'm going to do it with you, okay? After you pause the video, work on it on your own, and when you're ready, play it again, okay? See you soon. All right, so remember, we want to use this equation for the surface area of a sphere, okay? We're given the radius of our sphere is 3 centimeters, okay? And so what I'm going to do is I'm going to input 3 for my radius, okay, like this, okay, all right, and then it says to use 3.14 for pi, but I'm going to hold off on that for now, okay? For right now, I'm going to just write this, okay? And then so now I see from here, I can, according to PEMDAS, I should do the exponents first, okay? So then, I don't know if I can write it upside down. Let's give it a try. Pi times 9, okay? Now I'm going to do 4 times 9, which is equal to 36 times pi, and then 36 times 3.14. You guys can just do it on your calculator. Let's see. 36 times 3.14. I get 113.04, and this is area, right? When we write area, is it enough for me to write it like this? right? What am I missing for area? I have to write square centimeters, and it's written like this, okay? All right, are you ready for more? All right, okay, let's do a guided practice next. Oh, there's the answer to that if you need something more concrete for you to look at. Maybe it's too small on my whiteboard or there's a glare. Okay. All right, let's do the guided practice. This is in your book. I'm going to read the question and then you do it on your own by pausing the video. All right. All right, so guided practice number 3 says, what is the surface area of a sphere with a radius of 6 centimeters? Use 3.14 as an approximation for pi, okay? All right, so let's pause the video and you do it on your own and start playing it again when you're ready to check your answer with me, okay? All right, see you soon. Hey, welcome back. How was it? I hope it wasn't too painful. I think you probably got it. It's pretty self-explanatory, okay? So this is what we did in the example, but let's see. We're going to do the same thing with our guided practice number 3, okay? So we're going to use our formula or our equation for surface area of a sphere, which is S is equal to 4 times pi r squared. And in this case, we know r, right? And r is equal to 6 centimeters, okay? So 6 squared. And according to PEMDAS, which tells us the order of operations, right? We got to do the exponents first here. So 6 squared is 36. So 4 times pi times 36. And what is 36 times 4? I'm going to just do it on the side here. 4, 2, 12, 14. So it's 144 pi. And then we can use 3.14 for pi, okay? And so again, you can use your calculator. I'm going to do 144 times 3.14. And this is equal to 452.16. Now it's area, so we have to do square centimeters like this. Okay, so this is our answer over here. All right. Good job. Okay, let's go into another example. Okay, now here it says find the radius of a sphere given its surface area. Okay, so now we don't know the radius, but we want to figure out the radius. Okay, that's our unknown variable. All right. Now, it looks like I'm going to still use the equation of the surface area of a sphere, which is 4 times pi r squared, right? The surface area of a sphere. Okay, let me read the question, and then I want you to pause the video and try it on your own. Okay, after I read the question, and then replay the video or like play the video again, start it again, so we can kind of work on it together. Okay, all right, let me read it. A tennis ball has a surface area of 14,095.46 square millimeters. What is the radius of the tennis ball? Use 3.14 as an approximation for pi. Okay, all right. So pause the video, try to work on it, think about it. Remember, we're solving for r, the radius. Okay? All right. You can do it. See you soon. Hey again, how was it? You guys doing okay? Was it a little confusing, some of the steps? Well, no worries. We're going to go through it together. Okay? If you were able to get through it, let's check your answer and see if it's what I got too. All right. So I didn't work it out yet. so let's see, in here, they gave us a surface area. And so the surface area is 14,095.46 square millimeters. Okay. And then that's equal to 4 times pi r squared. Okay. So in this case, I just want the unknown variable on its own, right? Okay, so that means I have to get rid of the 4 times pi, right? And because 4 times pi times r squared is being multiplied to the variable r squared, okay, to get rid of it, what can I do? Well, I can divide both sides by 4 pi. Okay, if I do that, then this 4 pi cancel that 4 pi, and I just get r squared. Okay, so now I have r squared is equal to this gigantic number divided by 4 pi. Okay. Now I'm not gonna input in 3.14 yet. Okay, I'm gonna kind of save that for later. Because now I see that, well, how do I just get r? Because this is r squared. How do I just get r? Do you guys remember what I gotta do? Well, I don't know what you're saying right now. But what we have to do is we have to take the square root of r squared just to get r. Okay? All right? And so here, then r would equal the square root of this. 14,095.46 divided by 4 pi. Okay? All right. So let's use our calculator to solve it. Okay? I might use my phone as my calculator because I know it has a square root sign in my phone. Remember, if you don't have a calculator with a square root sign, what you can do is you can go on Google. Remember, I looked up Google Calculator last time, and you guys can find the square root function on the calculator that pops up when on Google you just write calculator search. All right, so here's my calculator. I'm gonna turn it sideways. Okay, so can you see it, or no? I don't think you guys can see it very well. Okay, so I'm gonna just solve for r. I'm gonna do my square root sign, and then 14,095.46 divided by, and I'm gonna make sure I put another parentheses for 4 times pi. Okay, so let me see, I got, I'm going to round it to the nearest 100. Got this. Is that what you guys got too? Now notice here, how come I didn't write square centimeters? I just wrote centimeters. Well, I just wrote centimeters because it is a unit, it is a length, a measurement of length. And so with that, it's not talking about area. Radius is not referring to area. It's just a unit of length, okay? And so it's just centimeters, not square centimeters, all right? Okay, let's move on to the next slide. Okay, so they just rounded it to the nearest tenth, and oh no, you guys, it's millimeters, not centimeters. Sorry, my bad. Okay, it's millimeters. Okay, mm is an abbreviation for millimeters. All right, now it's your turn. Okay, Let's do guided practice number 4. Okay. Now it says a spherical rubber ball has a surface area of 3,215.36 square centimeters. What is the radius of the rubber ball to the nearest centimeter? Use 3.14 as an approximation for pi. Okay, and what you can just do is you guys can just look at this guided practice outline, and you can just fill in the blanks of what you think happens and how to solve it. All right. Again, you're given the surface area of a sphere, but you want to find the radius, just like what we did here in this problem. Okay, so use this surface area of a sphere equation. Input the surface area, okay, and then solve for r. All right, so pause the video and let's see if you guys were on the right track. Okay. Hey, welcome back again. How was it? I hope it's getting easier and easier to compute the surface area and finding the radius with the given surface area. I know you guys are trying your best, so I'm really proud of all of your effort that you're putting in, okay? And so I'm just going to move on to the next slide, the answers, since this is just a fill in the blank, and you can see if, you're on the right track or not, okay? All right. So this is what we did. It's similar to what we did here with the example, all right? And the radius of the rubber ball is about 16 centimeters. Yay, we're at the end of our lesson. All right, good job. Thank you for sticking through it and trying your best and paying attention. That's all for today. Bye.